Good afternoon, everybody. Welcome to this session. My name is Mike Nelson. I am a tech evangelist for Pure Storage. I'm going to be talking about infrastructure as code in 11 minutes and 59 seconds. Why isn't it 12 minutes? Because Al won't give us the full 12 minutes. He only gives us actually like less than that. Yeah. All right, so what is IAC, right? Infrastructure as code. If you haven't worked with it already, it's the practice of managing and provisioning infrastructure through software and automated processes. At least that's what the dictionary says. Basically what you're doing is you're taking hardware and you're managing it through software. All right, so you're taking things and you're doing everything through software. It's infrastructure as code. All right, so codifying infrastructure. A lot of folks will say, how can you actually codify infrastructure? Because there's bare metal, there's physical switches you have to plug in, and you have to do things with cabling and all that kind of stuff. Yeah, you can't codify that unless you're using what? Software defined, right? So using NSX, you don't need those actual connections, right? You just do virtual connections. But at some point, you still have to use cable. There's still a physical aspect to it. What this is trying to do from an IAC standpoint is make it as easy as possible and as replicatable as possible. Replicatable is a word, I think it is, as possible that you can actually do this through software. You can manage and build infrastructure through software. So the declaration models of IAC, it creates identical infrastructure every time it's applied. Every time you apply it, it'll create the same thing, no matter what, unless you change the code that's actually doing the applying. Okay? So it's going to create identical every single time. It's both creative and destructive. All right? So we have IAC that can actually create things, and then we have IAC that can actually destroy things. All right? So creation and destruction. It's imperative and declarative. Now, if you don't know what imperative and declarative is, we'll talk about that in a second. And then necessary to reproduce identical configurations of infrastructure by code. That's exactly what it is. It's required to actually reproduce that identical configuration. So we talk about imperative versus declarative, because this is really an important point of IAC, is imperative is always what to do, declarative is what is wanted. All right. Now I admit 100% transparent. I stole these slides from somebody else because they were like really cool and I wanted to use them. But you forward imperative, when you talk about going to an actual pizza parlor, you have to go forward 1 mile, turn right, forward 2 miles, turn left. You're basically going through GPS, right? But if you're doing declarative, all you want to do is go to the pizza, go get pizza. All right. So you don't have to go through all these steps. You just say, I want to go get pizza. All right. And the rest works itself out. We take a little bit deeper, is imperative is going to say the starting point matters. It's difficult to audit. It's difficult to detect drift. No version control, not repeatable, so on and so forth. When you're talking about declarative, the starting point doesn't matter. It doesn't matter where you start because you've already declared it. It's already there. Okay? The engine determines how to get to the destination. You don't determine how to do it. Okay? The thing that's creating the infrastructure as code determines how to get there. Okay, and idempotent property and idempotent. Anybody know what idempotent is? Okay, mutable, immutable. All right, means it can be idempotent, can be deleted, not deleted. Repeatable in a pipeline, really critical when you're talking about CI/CD pipelines and being able to create things that go through a full automation process. IAC is the same way. IAC can be a complete pipeline process where you don't even touch it. You don't even have to trigger it. It's triggered by something else. Creates the infrastructure, and you just watch it go. That's it. Can be version control, can validate and detect drift, which is really huge in data centers today, because drift is something that happens all the time. You get configuration drift where one thing gets a little bit different than the other. You have a network card that's running this version of the driver, and all of a sudden you have another, got a Windows OS update or something that put a different version driver for that network card, and it changed something. That's configuration drift. Okay, so examples of frameworks you can use. There's Terraform, SaltStack, Bicep, which is used to be Azure Resource Manager. All these kinds of things. Anybody, Ansible, been pretty popular. Terraform is really popular. You have Puppet, Chef. The other one down there, Kubernetes. You can actually do IAC with Kubernetes. I don't know if you knew that, but you can. You can also use Docker, because Docker reproduces the same container every time. It doesn't change the container. Whatever's in the container is opened at the same time. So when you open a container, you have what you have. You spin up the same container, you're going to have the exact same thing. That's infrastructure as code. And then you have something called Pulumi, which is, kind of like the same thing as Terraform. And of course, you have scripts. You can do this all via scripts. You can do it via PowerShell scripts, via Python, your own scripting. You can do that. Look at SRM, what it used to be. If anybody remembers the old SRM, everything you had to do was via a script. You were reproducing everything via a script. That was infrastructure as code, believe it or not. That's what it was. In its infancy, but it was. Where am I? There we go. So the challenges we have are human error in setup. Obviously, you can always fat finger something. Something's going to happen. You have configuration, drift, and shift. So I talked about drift, but does anybody know what shifting is? When you have configuration shift, you get a stack of servers from HPE or Dell or whoever. Is everything identical in every one of those servers in that bare metal? Everything identical? Okay, everything's identical. Okay, now we're going to put the OS on. Is everything still identical in every one of those? That's what they call configuration shift. Okay? Duplication of errors. If something errors, in your IAC, it's going to error every single time. All right? It's not going to stop erroring. It's going to continue to error. And then technical debt. Actually, people learning how IAC works and how to create IAC, how to create the scripts, how to use the frameworks. There's a lot of technical debt there. Some of those frameworks are easier to learn than others. I'll be honest with you. Terraform is incredibly easy to learn. Ansible takes a little bit more, but once you get the hang of it, it's really kind of cool. SaltStack, you better take the time with that one, So, depends on what you pick. Do and do not. Do not document. IAC, believe it or not, this goes against everything I believe in. But IAC is not meant to be documented. The code is supposed to be documented. So the code is supposed to be self-explanatory. It should tell you exactly what it's going to do. You shouldn't have to write a separate Word doc that tells everything that the code's going to do. That's not what it's for. Do not make configs complex. Do version control, absolutely. Do reusable and modular code. Reuse code you will, in anything, okay? Do not reinvent the wheel. And do remain in and sustain compliance. That's really kind of important to folks who work in government, finance, all that kind of fun stuff. All right. And I'm almost out of time, but here I'm actually going to go through and take a look at something in Terraform. Maybe some of you use Terraform, so you know what I'm looking at here. The main.tf is where you actually describe what's going to be built by Terraform. So in here you can see I'm actually creating a simple Ubuntu VM, and I'm getting it all the variables that have come from a variable file, or I'm actually designating here, like the IP range, the subnet, things like that, SSH, all that kind of stuff. But this code does not change. Every time it's run, it's going to build the same thing, unless you go in and change it. So that's why you do version control, because version 1 will do this, version 2 will do this, version 3 will do this, version 4 will do that. All right, so when we actually run this thing, and I sped this up obviously because it takes a while to do this, I can do a Terraform init. It's going to go through and it's going to download the providers it needs to actually perform the scripts, which it does here. You're going to do something, now I'm going to do a Terraform, I'm going to be like, I want to apply this. No, wrong. Do a plan first. Terraform plan will show you exactly what it's going to do. It'll even output it for you for compliance reasons so you can see what happens. All right, so make sure you do a Terraform plan first. Tell you everything it's going to do. Now you can actually go up and once I clear the screen here, you can actually see it, do a Terraform apply. Terraform apply is going to do the same thing plan did. It's going to tell you everything it's going to do, but then it's going to ask you, do you really want to do this? And you're going to say yes or no. Okay, and then it's going to go through and create whatever you want. All right. I should have sped this up a little bit faster. All right, so once it's actually applied complete, it's built the VM. It actually tells you that it built it, and it gives you the public IP address and the resource group name, so you know how to actually connect to it. I do an AZ VM list, and it'll actually show me that VM that was created. As you can see here, it's using the same thing, the RG winning Joey, up here, the RG winning join resource group, and there's a Ubuntu server. So it created that. Now if I run that script again, it's going to create the exact same configuration, all right, that it created previously. Now what I'll do is I'll run something called a destroy. The destroy will go through and it'll look at something called a state file. There's a Terraform state file. That state file records, okay, what was actually done and when it did the apply. All right, so it's going through and it's comparing what is in that state file to what actually exists and making sure that nothing has changed. There's no configuration drift, there's no configuration shift. All right, and if it says everything's cool, then it'll actually go through and it'll come up and it'll say, do you really want to destroy this? And eventually you get to that point. Come on. You see, it's actually going through and looking at everything, okay? Here, do you really want to destroy it? There's no undo here, folks, all right? So you say yes, and it'll go through and just start tearing everything down step by step. Now, in IAC, there should be absolutely no errors in this, okay? So when you do destroy, it is destroying exactly what you did before. If you see errors in this, then you got a problem with the code. Okay, it should be fixing it for you, but there is a possibility that something happened to that state file. State files are shareable. Other people can use state files. They can mess with your state files. They can change your state files. Be very careful about that. Here's in VS Code, you can actually see these are the TF state files. This is the one that actually tells you what's going on, or it knows what's going on. There's also a TF state backup. It makes it automatically, so there's always a backup there. Okay? And this is the main TF again. This is showing you that I'm doing something a little bit different using pure storage, the Open Connect. I'm actually doing with storage now. Most of the time we're doing with VMs, right? Or we're doing this with infrastructure, bare metal. Okay? You can do this with storage. You can do this with networking. At Pure Storage, we actually, I was part of the team that created this where you can actually go through and do infrastructure as code with storage. So if you want the exact same storage allocated every single time, you can use our Terraform and you can do this. Now this isn't a vendor thing, all right, so I'm not telling you to do that, but there are a lot of other vendors that do it as well. From a networking aspect, I know Arista has some great stuff out there. So there's a bunch of other folks that do it. So I built the storage, even with iSCSI IDs and everything else, and now in a volume, and now I'm destroying it. And that's it. Thank you very much. I appreciate it. If you have any questions, I'll be right over there.